Hello everyone, this is problem number 53 on page 334 of your book, and it says simplify the expression. The first thing you're going to do here is you're going to distribute each one of these exponents inside of the parentheses. So this is what you will have. You will have in the numerator this 1/2 you multiply by each one of the exponents. So 2 has an exponent of 1 and a has an exponent of 1. So 1 times 1/2 and 1 times 1/2. That's the idea. So this will give me 2 to the 1/2 power and a to the 1/2 power. Next parentheses, you get 3 to the -2 power and b to the -2 power. Next parentheses, you get 4 to the 3/5 power and a to the 3/5 power. Now it's very important, this power law in exponents. If you have an exponent inside the parentheses, for example, if 4 were 4 to the 2nd power, you would multiply 2 times 3/5, okay, because you multiply exponents. In the denominator, we do the same thing. We have 4 to the -3/2 powers, a to the -3/2 powers, 3 to the 2nd power, b to the 2nd power, 2 to the 1/5 power, a to the 1/5 power. Okay, and there you are. You're done distributing each one of these powers. The next thing I'm going to do, I'm going to continue down here. The next thing I'm going to do is all of these negative exponents, I'm going to place them where they can be positive exponents. So if I have any negative exponents in the numerator, I bring them down to the denominator, and that makes the exponent positive. If I have negative exponents in the denominator, I will bring them into the numerator, and that will make those exponents positive, okay? So in the numerator, I can write 2 to the 1/2 power, a to the 1/2 power. That 3 that's negative, let me write my denominator here. That is going to come downstairs. So 3 to the -2 is the same thing as 1 over 3 squared. B to the -2 is the same thing as 1 over b squared. And that makes it positive. My next number is 4 to the 3/5 power and a to the 3/5 power. Now I'm going to work down here. Already I've brought down 2 terms. Now I'm going to work with all of these terms in the denominator. This number has a negative exponent. Let's bring it upstairs. So 4 to the 3/2 power. This one also, a to the 3/2 power. This one remains downstairs. This is 3 to the 2nd power, b to the 2nd power, 2 to the 1/5 power, and a to the 1/5 power. Okay, so far I distributed the exponent, and now I'm making all the exponents positive. Once you're done doing that, now we're going to use the commutative property, which lets you rearrange the order of these terms. And what I want to do is I want to have all my numbers next to each other and all my a's next to each other, the same thing in the denominator. So let's start upstairs. So upstairs I have 2 to the 1/2 power. I have 4 to the 3/5 power and 4 to the 3/2 power. Okay? And then I have a to the 1/2 power, a to the 3/5, and a to the 3/2. That's what you have in the numerator. Now in the denominator, same thing. 3 to the 2nd power, 3 to the 2nd power, 2 to the 1/5 power, and then I have an a to the 1/5 power, and I have b squared and b squared. So all I did was change the order of the terms in this expression. Okay? Next thing we're going to do is remember that exponent law that says if you have equal bases, you can add the exponents if you're multiplying. And remember, all of this is multiplication. Okay, all of this is multiplication. So we're multiplying. We have bases that are equal. I'm going to go ahead and add the exponents. I'm going to continue down here. For the numbers, notice I have a 2, 4, 4. These two have equal bases. I can add these two exponents. But then I'll have a 2 and a 4 to whatever power that gives out to. I think it's better if we do the following. I'm going to make them all the same base. So I'm going to make all of these have base 2. Okay? Because I can. Sometimes you can't make them the same base, but in this case, I can make all three numbers have the same base. So 4, 4, we can rewrite 4 as 2 to the second power. Okay, so then this number here, uh, 4 is equal to 2 to the second power, so I can rewrite 4 to the 3/5 power. I can rewrite that as 2 to the second power, which is your 4, that's this number, raised to the 3/5 power. And when we have a power raised to another power, I multiply powers. So this becomes 2 to the 6/5 power. Okay, that's this term here. I'm going to do the same with this one. 4 to the 3/2 power. Look at what happens. 4 to the 3/2 powers is 2 to the second power, which is my 4, that's your base, and then that's raised to the 3/2 power, and that is the same thing as multiplying exponents. That becomes 2 to the 6/2 power, which is 2 to the third power. Okay, so this is 2 to the 6/5 power, and this is 2 to the third power. So I'm going to rewrite this as this, okay? So I have in the numerator 2 to the 1/2 power times 2 to the 6/5 power times 2 to the third power. Okay? And then these a's here, let me go off to the side again. These are the same base. I'm multiplying, so that means I can add exponents. So I would have to add 1/2 plus 3/5 plus 3/2. And that equals, the common denominator here will be 10. So to make this 10, I would have to multiply 5 over 5. That gives you 5 over 10. To make this one 10, I multiply 2 over 2. That makes 6 over 10. And to make this a 10, I have to multiply by 5 in the numerator and in the denominator, so 15 over 10. And that all equals to 26 over 10. So that means that I'll have a raised to the 26 over 10 power. That's my numerator. And in my next step, I'm going to add these exponents because I have the same base, okay? In the denominator, I have 3 to the second power times 3 to the second power. I have the same base. I can add exponents. This will equal 3 to the 4th power. Now, why didn't I make this 3 a base 2? Because I can't rewrite 3 as a base 2 number, okay? So these numbers, I have to keep separate. I can't join them like I did with the 2 and the 4, okay? And now my a is a to the 1/5 power, and my b's here, b times b, b squared times b squared. I add the exponents, and that's b to the 4th power. Now I'm going to add these exponents because I have the same base. Let's do this off to the side here. So I have 1/2 plus 6/5 plus 3. 1/2 plus 6 over 5 plus 3. Common denominator here, again, 10. So to make this 10, I have to multiply the numerator and denominator by 5, and that gives you 5 over 10. Plus, to make this a 10, I have to multiply the numerator and denominator by 2, which makes 12 over 10. And to make this a denominator of 10, I have to multiply 10 in the numerator and 10 in the denominator, which gives you 30 over 10, which is 3, right? 30 over 10 is 3. And that adds up to 42 plus 5, 47 tenths. Okay, so I have 2 to the 47 tenths power times a to the 26 tenths power, all divided by 3 to the 4th power, 2 to the 1/5 power, a to the 1/5 power, and b to the 4th power. And there's more we can do with this to simplify it more. Anytime I have the same base in the numerator and the denominator, I can keep simplifying, because same base, when they're in a quotient, then what I need to do is I take the exponents and I subtract. Okay? Let me bring this down a little bit. Okay? So what I'm going to do here is, since 2 and 2 are the same base and they're in a fraction, I can subtract 47 tenths minus a fifth. So this is 47 over 10 minus 1 over 5. Common denominator is 10, so that equals 47 tenths minus 2 tenths. And that equals 45 over 10. And I can reduce this. I can divide by 5 in the numerator and get a 9, and by 5 in the denominator and get a 2. Okay? So that gives me, for this base 2 number, that gives me a total of 2 to the 9/2 power. Okay? And let me draw this denominator. Okay. Now I can also subtract exponents because I have a. A is the same base. I can subtract these two exponents. Let's do that. So 26 tenths minus 1/5. Common denominator is 10, so that's 26 tenths minus 2 tenths, and that gives you 24 tenths. And I can reduce this by dividing by 2. So this is 12 over 5. That means that this is a 12 to the 12/5, a to the 12/5 power, okay? And in the denominator, I'm left with 3 to the 4th power. 2 is not here anymore because we combined these. We combined these bases, and we were left with this. And we also combined these two terms and left with this. So in the denominator, I'm left with 3 to the 4th power and b to the 4th power. Okay? Okay, so what we're going to do here for this time is I am going to keep this answer and say that we're done. Okay? We're done. This is an acceptable answer, okay? If you go ahead and you take these expressions and turn it into radical, then you can further simplify. But for us, we can leave it like this. This is simplified enough, okay? I hope you understood this video. It's a very long process, but if you practice it, it's good for practicing and being careful. You have to be very careful with each one of these little steps and make sure you don't mess up your additions, your common denominators. Go back, try it on your own, see if you get the same answer. Have fun with this. This is very fun work. I'm sure it's fun for you too. Yeah, right. It's very fun and entertaining. I'll see you in the next video.